Today, we're going to go over alkene and alkyne nomenclature. In alkenes, remember that we have double bonds, and in alkyne, we have triple bonds. The first thing that we need to do is identify the continuous carbon chain that contains the double or the triple bond. So it doesn't matter if the chain is longest, for example, it's longest without the bond, like in this case, the bond cannot be a substituent. So what we're going to do is we're going to count where the double bond is part of the carbon chain. So in this case, just by identifying, I know that the straight line gives me the carbon chain that contains a double bond. So that means that this one over here is going to be a substituent. And we'll see what substituent is in a minute. Then it says, number 2, start counting the carbons from where the double or the triple bond are closest to the end. So in this case, we have two options. We either start counting 1, 2, 3, 4, 5, and my double bond is in carbon 5, or 1, 2, 3, 4, and my double bond is in carbon 4. So if I start numbering from the right, that means that I have the lowest number possible. So I'll just keep that numbering. And let me finish. So I have 4, 5, 6, 7, 8, 9. Then it says identify the substituent. The substituent is this one over here. So let me give it a name. It has 1, 2, 3, 4 carbons. So it's butyl. Then it says, give it a name. Substituents are arranged in alphabetical order, then the location number of the double or the triple bond, and then the parent name with termination "-ine" or "-ine". So we only have one substituent. This substituent is in carbon 5. So I have 5-butyl. Then I need to say where the double bond is. The double bond is in carbon 4. And then I need to give it the name. I have 9 carbons. So it will be nonane, but because we don't have an alkane, it's going to be nonene. Nonene because I have a double bond. So that is the way that we're going to be naming alkenes or alkynes. It's exactly the same rules for alkynes. Let's see some extra rules for when we have some other cases. It says, number 5, if you have more than one double or triple bond, use the prefixes for quantity, di, tri, tetra. So this would be 2, this would be for 3, this would be for 4, etc. Before the "-ine" or the "-ine. All bonds need location numbers. So we have two examples here. My longest chain, again, is the straight one. So this one is the one that gives me the most carbons. I'm going to name him where the double or the triple bond are closer to the end. So I go 1, 2, 3, 4, 5, 6, 7, 8. I identify my substituents. This is an isopropyl. And this is a halogen. This is the chloro. And then I put my name together. I go first substituents in alphabetical order, so it's going to go 3-chloro, 6-isopropyl, and then I'm going to say where the double bond is. So my double bonds are in carbon 1 and in carbon 3 and in carbon number 5. So I go 1, 3, 5, I have 8, oct, tri, ine. So this one means that I have double bonds. This one means that I have 3 double bonds. And this one means that I have an 8 carbons in my chain. And these ones tell me where the double bonds are. So it is very systematic what we do. Now let's see this next one. This next one has triple bonds. Again, I identified this as a straight line. So I have 1, 2, 3, 4, 5. I have 5 carbons in my chain. I have only one substituent, the chloro group. I have 2 triple bonds. There are in 1 and 3. So I start putting the name together. So it's going to be 5 chloro, 1 3 pen triine. So again, this is the triple bond. Oh no, it's not tri because I only have 2, pentadiene. So I only have 2, so it's diene. So let's see it again. So this means the triple bond. This means that I have 2. This means that I have a 5 carbon chain. This tell me where the triple bonds are. And obviously the substituents. So that is how we're going to be naming alkenes or alkynes where I have more than one. Okay, another case. It says if you have a double and a triple bond, one is not more important than the other. What we need to see is that when we number, we give the smallest number possible. So the bond, we start numbering from the bond that it's closest to the end. So for example, in this case, I have 1, 2, 3, 4, 5, 6, 7, 8, right? Because the double bond in carbon 1 is the closest to the end. The name, it's going to come in before ein. And that's because it's the alphabet. So let's put the name together. If the double bond comes first, I go 1, 6, oct, die, in, and then I name the triple bond 3, ein. So this is saying that the triple bond is in carbon 3. This is saying that I have 2 double bonds where in carbon 1 and 6. So everything has to keep an order. It is very systematic. So in this case, the double bond is here. I can start naming 1, 2, but the triple bond is right in the end. So I go 1, 2, 3, 4, 5. So this numbering is not correct. 4, 5, 6. So in comes first. So I go 4, xene, 1, ein. Right? So this is the triple bond. This is one double bond that it is in carbon 4. So the last one. In this case, I can go 1, 2, 3 or 1, 2, 3. Let's see where my numbering. I have 2 substituents in carbon 2, so I'm going to keep that numbering. So I'll start 1, 2, 3, 4, 5, 6, 7, and 8. So now let me identify the substituents. I have a chloro, I have a methyl, and I have a cyclopropyl. So I put it together. So I first start with the alphabet. It's CH, CY. Chloro comes first. So I have 2 chloro, 7 cyclopropyl, 2-methyl, and then come the double and the triple bonds. First the double. So I have 3-octene, 5-ine. So again, the 5-ine tells me where the triple bond is. The 3N tells me where my double bond is. And here I have my substituents in alphabetical order. So those are some of the cases that we can encounter when we are naming alkenes and alkynes.